Somehow Palpatine has returned.
Somehow I've been invited to the Toolroom Takeover of 2026, the summer Secret Santa for machine tools enthusiasts, and I'm making a gift for none other than Alec Steel.
Actually, everybody's been pronouncing it wrong all these years. It is Steely, Alec Steely.
Well, Mr. Steely has been there since the very beginning of my journey in metalworking. So I want to do something special, to pay the due respect to the 13 years of butterfly effects involved in this opportunity to personally say thank you for all the inspiration I got from him. AKA a custom fountain pen. Of course, I never made one before, but how hard can it be? The first problem to solve was the loading mechanism. Fancy fountain pens don't use cartridges, they have an internal piston mechanism, so you dip the nib in an inkwell and suck it up. And there's a whole variety of systems: syringes, pumps, vacuums, bladders. These mechanisms are a big part of what makes fountain pens so interesting, so I want to come up with my own.
Let me show you what I came up with.
Top of the pen screws off, bottom of the shaft screws into the piston, piston comes down, sucking the ink, bottom of the shaft screws off, top of the pen screws in. We got one big O-ring that does the sucking, two small O-rings that seal the sliding shaft, and a bunch of parts. The plunger itself is in two parts that threads together to squeeze the O-ring enough to seal the tube. These two caps keeps the O-rings for the shaft in place, plus the bottom one has the thread that allows the shaft to grab and move the piston down with this threaded thing here.
Let's make it.
I turn everything out of stainless, which is regarded as a somewhat abusive material with a drinking problem and is indeed a bit hard on the tooling, but as long as you go slow enough and lubricate properly, it machines beautifully. What actually troubled me was having the two halves of the piston screwed together with no way to lock them. Given all the twisting and turning of the locking procedure, they seem destined to disassemble themselves over time. But there must be a good reason if glue has been around for 200,000 years. So I was optimistic about it. And speaking of things that troubled me, super cheap micro tooling like this one were key to cut a lot of features in this project, and they exuded all the dependability of a glass needle. But they were actually very sturdy and performed great. Question: why does the threading tool cross the lathe? To cut the chamfer. Next are the two caps. To drill these holes, I'm using the DRO function for drilling in a circle. Very handy stuff. Also, few things will make you feel relaxed, like tapping M2 blind holes. Working with live wires might be one. A little head job on the M2 screw, and we're done. If that's not a festive sound, I don't know what is. And nothing of this would have been possible without Onshape, who has kindly accepted to sponsor this video. I chase these guys for this collaboration because I've loved CAD but hated CAD programs for 20 years straight until I tried Onshape 2 years ago for the Marble Clock project. First of all, it's cloud-based, so Windows or Apple doesn't matter, you don't have to install it, it runs off your browser, it doesn't crash, it works. Sorry. And collaborating is super easy, you just log in the same project and work, but this time your dumb colleague can't lose critical files around anymore. Second, they let you try the Pro version for free 6 months, which is very cool. And to top it all, if you're not just a hobbyist, they got a built-in PDM and have just rolled out Onshape Labs, an early access to the AI features they are developing to speed up design and a whole chain that leads to production. I did my fair share of mechanical design in a company and I would have cared to have Onshape, so give it a try using my link in description. This way they'll know I sent you. And enjoy it, because it's an incredibly well-made tool. Back to the build. With the plunger done, I just had the shaft and the piston grabber to take care of. One nice thing of the collet chuck is that you can hold threads with no harm and quickly modify any bolt. But since collets don't really like to grab parts shorter than their diameter, I use the drill bit of the proper size as a backer to trim the other side. The piston grabber threads on the shaft with an M3. Glue was my answer to keep that in one piece as well. To finish things off, I put together a little test rig to see if this contraption was going to actually suck something or just suck on itself. Look at that! Like a golf ball through the garden hose. But it wasn't time to bust out the pizza and the mandolin just yet, cause this was arguably the easiest part. I chose to make a fountain pen because it's one of those life tools that you can really infuse with a soul. And this is the pen of a blacksmith named Steel nonetheless. So it was absolutely imperative to make both the body and the cap of the pen out of raw forged steel. But not just any steel. I was going to transform an old vintage hammer. Because forging. I also made a little rounding die to give myself a fighting chance to keep the final piece in tolerance enough to be machined without critical failures. More on that later.
Die by my hand! I forge across the land, making a sink a span!
Sorry, I had to get that out of my system. Now, forging on your balcony is generally frowned upon by the lawyers of your neighbors. But my neighbors love me for some reason. Plus, this is a coke forge. Coke is a particular type of baked coal, very porous and very pure, so it burns hotter than hell, and most importantly, it burns clean and smokeless. So I could lit the fires without having people across the street frantically call the fire department. Man, I made that forge 10 years ago and only used it for one project. It felt good putting it back together. Coke requires a pretty high temperature to ignite, and there are a number of neat traditional ways to do it. My way is to dump some barbecue charcoal, lighting fluid and torch it. Then when the lighting fluid is almost burnt off, I turn on the air and pour the coke over it. It works every time. Gotta love the smell of a burning forge in the morning. It instantly brought back all the memories. A heat wave in the hottest summer ever recorded is the perfect forging weather. And after a couple of hours, the muscle memory was starting to kick back in, the technique was improving, and things were slowly starting to go somewhere when... Say goodbye to my little friend. So I burnt the hammer. I wasn't happy, but I can say that I was devastated because plan B was a lot more sensible. Plan B was to take a 16mm mild steel bar and hammer it down to 15, which admittedly was lame, but at noon with 42 degrees Celsius in front of a roaring forge, I felt like steel is steel and that's what counts. Problem: mild steel likes rust. Rust like water. Ink is made of water. My solution was to bore out most of the mild steel and insert a ground stainless steel tube. The problem was that due to the inconsistency in the forging, I wasn't sure I had enough meat all around to pull it off. In the end, the body was fine, but the cap had turned out to be a much closer call. Nice fit though. To finish, I turned some rubber caps to seal off the ends of the forged tubes and prepared a nice bath of cold blue. Don't make that face, I'll put it back in the bottle when I'm done. A bit of whey oil, and I could forget about these parts for a minute, because the next challenge was to cut an internal thread on this end of the stainless tube to screw in this cap. So I have 0.5mm of wall thickness on the tube. The plan is to use a 0.5mm pitch threads with a 0.28 depth, so I can use a 0.3 relief cut in the back and still have 0.2mm left of meat to keep the tube together. The only saving grace of this operation was that, being a left-hand thread, the cutter was going to be pulled out of the tube instead of flying towards certain distraction way past the relief line. Unless some moron forgets to reverse the motor on the final passage, that is. But disappointment aside, a major perk of having a forged exterior as a separate piece was that I could just part off the mistake and start over, without reforging everything. Now, with the thread in the tube done, it made sense to turn this matching cap. But this cap, all this hardware in fact, has to be Damascus. It's Alec Steele's pen, of course it had to be Damascus. However, by this point I'm sure you can imagine I couldn't do it on my own. Luckily, it was the man of steel himself to offer me the solution. Damasteel is the world's top dog in manufacturing stainless steel Damascus, and when I reached out, they were happy to chip in for the gift and sent over a bar of their gorgeous Heimskringla pattern. Sorry for butchering that, and thank you, Damasteel. Nice. So things were looking up, but I still had to solve one of the most critical aspects of a successful pen, the cap. Getting a snappy action and a good seal on a cap is the result of many, many iterations that I absolutely didn't have time to try. I did sniff my way around a couple of options, but ultimately I needed something reliable, quick, and the good old screw-on cap of vintage fountain pens was the safest option. So I'm moving to this section, starting from the back to make sure I get a good fit with the body, and then we'll move to the more complex front bit. Nice, now the front. I started with a cutout for the O-ring that will seal the cap. Then I prepped the section for the threads and turned down the rest to give clearance for the threading tool. Which brings us to the problem of cutting the thread for the cap without crushing on the shoulder. A useful thing to know when cutting threads on a lathe is that if the chuck and the lead screw are turning in the same direction, you get a right-hand thread, so righty-tighty. While if they're going against each other, like in a rolling mill, you get a left-hand thread, lefty-tighty. Because of this mechanic, right-hand threads pull the tool toward the chuck, risking to crush, while left-hand threads pull the tool away from the chuck, making for a much more relaxing experience. Of course, 99.8% of threads are all right-hand threads, and this makes no exception, or it would be super counterintuitive to open the cap. However, if you set the threading tool upside down, and if your lathe allows to switch the direction of the lead screw, you can run the motor in reverse and have the spindle and the lead screw moving in the same direction while the tool gets away from the chuck, which allows to cut thread at full speed with carbide inserts without the certainty to crush. Be careful though, because some spindle nose unscrew themselves when put under load in reverse, so check before trying this trick. The matching stainless sleeve for the cap was pretty much the same story, but on the inside, so I cut the threads blind, being very careful in setting the tool and going by the numbers on the arrow. Once the threads were done and a huge pole was finally dislodged from my throat, I could finish the frontal portion of the pen. To complete the front of the pen, I also needed a nib and a feed, so I stole them from a vintage pen made in the 1920s. Because vintage nibs are the MILF of pens. They can do things modern one can't. If you know, you know. Admittedly, I could have done a better job, but it worked, so... At this point things were shaping up, but I was still debating how to put together this pen. Especially this section, because this chamber is full of ink, and it cannot come loose when screwing on and off the cap or it's a disaster. So I went to the good book, searching for answers. Gotteswinter, 2517. The path of the righteous machinist is beset on all sides by the iniquities of his skills and the tyranny of time.
Blessed is it which in the name of quickness and practicality shepherds the weak in the valley of fasteners, for it is truly the keeper of shafts and the holder of threads, and you will know its name is Loctite 648.
Amen. Loctite 648 is truly awesome stuff. In fact, it's also what will keep together the forged exterior and the stainless tube as one piece forever. I was at the final stretch. I just had to make the top knob of the pen to operate the piston and the tip of the cap with the clip.
I think I need a plan B. We're there. Okay, the clip is the last bit I have to machine, and it's kind of tricky because it has a very thin section to be a clip, and time is running out, I'm running out, and material is running out.
If the desperation in my eyes wasn't a strong enough clue, yeah, I was about to set up something janky and potentially ballistic in the vise. Luckily though, I decided to wind down a bit, and the right answer hit me like a kangaroo kick. A fixture, of course! Guys, social media are a waste of time only if you follow the wrong people. At this point, all the machining was done, leaving only the etching as a last viable option to scrap the project. Because Dama steel, being stainless, requires a bit more punch than some ferric chloride and a cup of coffee. Meat, steaming hot hydrochloric acid, very nasty stuff, and some ferric chloride and vinegar on the side. It went fine. However, to get the black out of the stainless, the parts should have been hardened, which would have required a whole lot of equipment and experience I didn't have. So sadly, it wasn't an option. The real tragedy is that I was stupid enough to rest the flat faces on the bottom of the jar instead of keeping them suspended. So where the pattern should have looked the best, it actually looked the worst. And I don't have words strong enough to express the disappointment in my own stupid head. But the show had to go on because tick-tock, tick-tock, time wasn't on my side. I'll say though, the white edge and the black steel look very nice together. Sunday, 10 PM, final assembly and test, shipping deadline on Monday. The O-rings inside the piston don't hold air as they should, so when you
discharge the ink from the piston, pressing down, it spits out. The piston is horribly stiff for some reason. Yeah.
Unfortunately, relieving a Smurf wasn't the user experience I was really going for.
I can technically unscrew the back and pull out the piston.
But the piston was jamming on the threads, and the threads were very thin. It could ruin them, strip them, sink the whole project.
So I really had two options. The first one is to lower the sails and end what it felt like a journey of 100,000 miles on low, or something is moving. I don't know which part. Yes!
The threads were fine, by the way. I added this O-ring to put a stop to the gushing fest. Made sure the piston grabber and the shaft could never ever come apart, Loctite or not. I reduced the Teflon washers that were jamming on the barrel and faced down these O-ring pockets to get more compression and a better seal around the shaft. There must be a joke in there somewhere, but plus an extra O-ring on the top of the pen to make the whole system airtight. In hindsight, these were all pretty obvious flaws. Did I mention I had never done a fountain pen before? Yeah.
New assessment, this thing is freaking awesome! Jesus.
In the end, I sent the pen to Alec the next day, on schedule. I also made a little trinket for Jamie, but you'll hopefully see it in Alec's video, because now there's a gift for me to open.
I'm very excited because Mike and Hazel from Chronova Engineering sent this one. So I get a chance to see what real machining looks like. Because they make some pretty incredible stuff over there. What is it? Ooh. See? This is professionalism. Oh my God. Whoa! This is so funny. You make a pen from steel, you get a pen for steel. Oh man, this is sharp. what an adventure. I just wanted to say thank you to my mate Eric with a K for organizing this whole thing and to be deranged enough to include me. Thank you to Chronova and Alec, plus Yuri, Marius, Northern Engineer, Cloud32, MBR Works, Jonesy, and I did the thing. It was an honor to share the battlefield with them. So please stop having a life for a moment and binge watch the whole playlist because it's truly a quite amazing thing. Thank you to OnShape for the support. So please also become a CAD nerd and check the link down below. Thank you to Damastil for the material, but most of all, thank you to you. Because without your interest and your support and your eyes, nothing of this could happen. So thank you so much. And if you are even more deranged than Eric and want to support directly what I'm doing, I have a Patreon now. Yay! There's a link down below for that as well. And I'll see you in the next one. Cheers!